Nearly 4.5 billion kilometers from Earth, sunlight is little more than a distant glow. Out here, deep in the dark, sits a massive blue sphere. It is so far out that a single trip around the sun takes 165 Earth years. Entire generations of humans are born and pass away before this world completes a single orbit. This world is a violently active environment, tearing through the darkness with massive storms and chaotic, raging winds. That combination, an atmosphere raging with intense energy in a place starved of solar heat, makes Neptune one of the most profound mysteries in our solar neighborhood. Long before we could see Neptune clearly, we knew it had to be there. In the early 19th century, astronomers noticed something strange about Uranus. Its orbit was irregular, pulled slightly off course by the gravity of an invisible, massive object lurking further out in the darkness. A French mathematician named Urbain Le Verrier, along with John Couch Adams in England, set out to locate this ghost planet using nothing but pure mathematics. They calculated exactly where a massive object would need to be to pull Uranus off its predicted path. In September 1846, astronomers pointed their telescopes precisely at Le Verrier's mathematical coordinates, and there it was. Humanity had successfully discovered a planet using a pencil and paper. But predicting a planet's location is very different from actually going there. The elegant equations on Earth gave no hint of the brutal environment waiting out in the dark. Our mathematical blueprint was correct, but the physical reality of Neptune turned out to be a chaotic system, far more dangerous and complex than the numbers ever suggested. If we were to actually travel there, our descent wouldn't begin at the atmosphere. It would start millions of kilometers out, navigating through Neptune's own miniature planetary system. Neptune is surrounded by faint, dark rings. But instead of smooth, even bands of ice and dust, the material is bunched together into dense, clumpy arcs, held in place by the gravitational tug of a small moon named Galatea. Looking at this orbital diagram, you'll see Neptune's largest moon, Triton. Notice its path. While Neptune rotates one way, Triton moves in the exact opposite direction, a retrograde orbit. Moons that form alongside their parent planet do not orbit backward. This trajectory indicates Triton was once a dwarf planet in the deep solar system, eventually snared by Neptune's massive gravity. And despite sitting in a deep freeze, Triton is violently awake. In 1989, we captured images of dark plumes erupting from its icy crust, spewing material straight up into space. Neptune acts as a giant gravitational net. It catches wandering bodies from the deepest parts of space, traps them in orbit, and slowly tears at them. Moving past the moons, we finally hit the planet itself. As we punch through the upper layers of deep blue methane gas, the temperature immediately plummets to minus 200 degrees Celsius. But the cold isn't the biggest threat here. We are instantly caught in wind bands whipping around the planet at over 2,000 kilometers per hour. That is faster than the speed of sound on Earth. These supersonic jet streams breed colossal storms. When we flew past in 1989, we spotted this, the Great Dark Spot, a singular, monstrous vortex large enough to swallow our entire planet whole. Yet, unlike Jupiter's ancient red storm, Neptune's weather is highly unstable. When we pointed telescopes back at Neptune years later, the Great Dark Spot was entirely gone. New storms simply open up elsewhere, drifting like giant shadows before dissolving back into the gas. It is an environment of constant chaotic motion, and it forces a very basic question. How does a planet completely starved of the sun's warmth power the most aggressive weather in the solar system? This cross-section shows us where that energy actually comes from. As we dive deeper beneath the clouds, the gas is crushed under immense weight, transitioning into a dense, superheated ocean of water, ammonia, and methane. Down in this fluid layer, something highly unusual is happening with the planet's electromagnetism. Neptune projects a massive magnetic field, but it is wildly tilted and generated completely off-center, away from the planet's actual core. Sinking even further, the crushing force reaches critical levels. The pressure down here is so extreme that it begins to tear molecules apart, literally ripping the carbon directly out of the surrounding methane gas. Those isolated carbon atoms are then squeezed together into crystalline structures. Deep inside Neptune, there is a theoretical process where millions of tons of diamonds are slowly raining downwards through an alien ocean. All of this intense internal friction, compression, and chemical separation generates an enormous amount of heat. Neptune radiates significantly more energy outward into space than it receives from the sun. That deep internal furnace is what reaches up and drives the supersonic winds at the surface. The serene blue sphere seen through a telescope masks a deeper reality. A freezing outer shell conceals an incomprehensibly hot, high-pressure dynamo, but almost everything we just explored about this system relies on a very thin slice of data. We owe nearly all our close-up knowledge of Neptune to one machine, Voyager 2, which flew past the planet for just a few hours in August 1989. Since that brief encounter, humanity has left it completely alone. Decades have passed, our technology has advanced exponentially, and yet we have never sent another probe back. Neptune holds a critical position in space. It sits right at the border of the Kuiper Belt, marking the boundary line where the familiar planets end and a vast icy expanse of debris begins. If a modern spacecraft were finally sent to establish a permanent orbit, the discoveries could be staggering. We could map the shifting magnetic field, watch the supersonic storms evolve in real time, or finally determine if a liquid water ocean sits trapped beneath Triton's frozen crust. Until we return, Neptune remains a massive blue ghost out in the dark, a humbling reminder that we have barely scratched the surface of our own cosmic backyard. This world marks the boundary where the familiar planets end and the enormous unknown begins.